Now let's look at evenly spaced sets. These sets are basically sets in which the gap or the distance between any two successive elements is constant. Let's look at this example: 2, 5, 8, 11, 14, and 17. This is an evenly spaced set because the distance between 2 and 5 is 3, and the distance between 5 and 8 is also 3, and the same thing between 8, 11, 11 and 14, and 14 and 17. Therefore, this is an evenly spaced set. Let's look at another example: a set of consecutive integers 2, 3, 4, and 5. Again, the distance between 2 and 3 is 1, and the same thing between 3 and 4 and 4 and 5. Therefore, a set of consecutive integers will always be an evenly spaced set. Let's have a look at another example: a set of consecutive even integers. The distance between 2 and 4 is 2, and the same thing between 4 and 6, 6 and 8, and 8 and 10. Therefore, a set of consecutive even integers will always be an evenly spaced set. You might be asking yourself, why are we going over evenly spaced sets? Well, we're doing so because the GMAT tests you not only on whether you're able to solve problems correctly, but also on whether you're able to do so in a timely manner. And recognizing that a set is evenly spaced will allow us to do that, because we will be able to use the following two equations or two formulas. Equation 1 is the number of elements in the set is equal to the maximum number in the set, which is the largest number in the set, minus the minimum, which is the smallest number in the set, over the distance or the gap between any two successive elements, plus the 1. Equation number 2 allows us to find the average, which is equal to the max plus the min over 2. So let's apply these two equations or formulas on a GMAT question. A question might ask you, how many multiples of 3 are there between 6 and 126 inclusive? Inclusive means including the 6 and the 126. This set has the number 6, 9, 12, and so on up to 121, 123, and 126. Recognizing that this is an evenly spaced set because the distance between any two successive elements is 3 allows us to use equation number 1. We can use equation number 1 to find the number of multiples or the number of elements in this set, which is in this case going to be equal to the maximum number, which is 126, minus the smallest number or the minimum, which is the 6, over the distance, which in this case is the number 3, plus the number 1, which is going to give us the answer, which is 41. So the number of multiples of 3 in the set is equal to 41. The GMAT doesn't only check your ability to solve questions quickly, like these formulas allows us to do, but it also tests whether you're able to pay attention to detail. For example, let's try the same exact question, but with different numbers. Instead of 6 and 126, let's use 5 and 127. The question would now ask, how many multiples of 3 are there between 5 and 127 inclusive? So to solve this question now, what is the minimum and the maximum? The minimum in this case is not 5 because 5 is not a multiple of 3 and therefore it's not part of the set. The same thing with 127. 127 is not divisible by 3. It's not a multiple of 3. Therefore, it's not part of the set. Therefore, the minimum in this case, the minimum multiple of 3 between 5 and 127 is going to be 6, and the maximum multiple of 3 in this set is going to be 126. Therefore, the equation or the solution is going to be exactly the same. N is going to equal to 126 minus 6 over 3 plus 1, which is also equal to 41.